Yes. What are alpha radiations? How do you explain alpha radiations? What are these?
They have the helium nucleus.
They are helium nucleus with two electrons are knocked off. It means their charge is positive too. And what about the ionizing power of uh, helium nucleus or alpha particles? I mean, if you compare it with alpha, beta, and gamma radiations,
Very high.
very high, the most highest ones. Okay. What about the beta radiations? Quickly, beta ones.
They are negative charged and fast moving electrons.
Absolutely okay. That's fine. Okay, so that's all right. Now, important thing is beta radiation. We were there that we actually at that point their penetration power is somewhere in the middle. So you can say that their penetration power is less than the gamma radiation, but more than the alpha radiation. You can write it down, please, if you already done that. Till where we have done actually yesterday. Ibrahim, do you remember?
So we were supposed to do gamma
Gamma was
rays in this class.
Is it? Beta is done.
Yeah,
yes.
we didn't do gamma rays.
Okay. So now put a heading gamma and let's do it right. First of all, the representation. So the gamma rays are represented by this sign. And how does this sign look like? This sign look like this. Not this way. This, sorry. It's this way. This is your gamma radiation sign. Alpha, beta, and gamma. Remember that these are the most penetrating rays and the most dangerous rays as well. Okay. So the representation of gamma rays are this sign. The second important thing is what are gamma rays? Remember that gamma rays doesn't have any charge on this. Okay. So gamma rays have no charge on them. They are simply very high frequency electromagnetic radiations. That is the first point for the gamma rays. They are very high frequency electromagnetic radiation with mass and charge equal to 0. Please write it down. There another representation of representing the gamma rays is this. Mass number is 0 as well, while atomic number is 0 as well. They neither turn at cathode electrode or they neither turn on anode electrode. Gamma radiations are very high frequency electromagnetic radiations. Their mass and charges are 0. Second point. Who will tell me if in electric field, which way they turn towards? Cathode, anode, or they are undeflected by any of the electrodes?
So they're undeflected, right?
They are undeflected because they do not have any charge. So you can say that in electric field, gamma radiations are undeflected by cathode or anode. In electric field, gamma radiations are undeflected by cathode or anode as gamma radiations have no charge. As gamma radiation has no charge. As gamma radiation has no charge. What about the speed of gamma radiations? What will be the speed of gamma radiation? They are electromagnetic radiations. So what will be the speed? Who will tell me? Any wild guesses?
It's fast.
No, definitely it's fast, but what will be the speed? Alpha radiations are moving with the speed 1/10 the speed of the light. Beta radiations are moving with the speed nearly equal to light, and they are moving with the speed of light because they are very high frequency electromagnetic radiation. So Gamma radiations are moving with the speed of light. Gamma radiations are moving with the speed of light. Ibrahim, what is the expected Eid day in your places where all of you live, Ibrahim and others?
Expected like what?
An Eid day.
Eid, I'm not sure, like in 10 days probably.
No, no, no. I don't. It's on next Monday or Tuesday. When it comes, I will ask you. No worries. Maybe you don't know,
Okay.
but ask your parents about it so that we will arrange our classes accordingly. Because definitely, so in some place, in some Arab countries, we have Eid one day before Pakistan, so I have to see accordingly. Okay, so we will see to it. Anyways, no worries. Okay, what about the penetration power? Remember that because they are very high frequency electromagnetic rays, so their penetration power is very high. So you can say that gamma radiation has the highest or very high penetrating power as compared to alpha radiations. Sorry, gamma radiations have very high penetrating power as compared to alpha and beta radiations. They can be stopped by the thick layer of steel or concrete. They can be stopped by the thick layer of steel or concrete. But few centimeters of dense lead, but few centimeter of dense lead does not stop it at all. So it means that they can easily pass through air, they can easily pass through the few meters of air and can easily pass through the concrete or steel. Right. So basically, this is what the high penetration power of that. Now, what about the ionizing power? Remember that alpha particles being the heaviest, they got the highest ionizing power and they got the lowest one because they do not have mass. So you can say gamma particles or gamma radiations have the lowest ionizing power. Gamma radiations have the lowest ionizing power as compared to alpha, beta, and gamma radiations. As compared to alpha, beta, and gamma radiations. Another point now. How do you see when these rays are actually passing through the magnetic field? What do you think of it? Remember that in magnetic field, gamma radiations are also shown no deflection. So in magnetic field, gamma radiation shows no deflection. Gamma radiations show no deflection. Gamma radiation show no deflection.
Sir, alpha particles have the highest ionization, right?
Yes, because they are the heaviest, right? After that, beta, and after that, gamma. Okay, guys, one of my question: alpha particles show deflection, beta particles show deflection in magnetic field. What is the difference? Any one of you? Gamma didn't show any deflection in magnetic field, but alpha and beta do show magnetic field. I mean, in magnetic field, they do show deflection. But what is the difference then? How do you identify which one is alpha and which one is beta? Ibrahim, Asjad, Yamna,
By their
Safiullah.
speed.
No, no, but how do you check the speed in magnetic field? Remember that there is a thing here. See, when you have a magnetic field, you show magnetic field by two ways. I will tell you in electromagnetic electromagnetism. One way is to write your magnetic field like this. It means out of the page, and another one is called as into the page. What is this? We will talk about this while we will be studying magnetic field. The important thing is when alpha particle goes from here, it will deflect, for example, in this direction. Beta particle will deflect in opposite direction. So both will deflect, but both will not deflect in same direction, but in an opposite direction. So when you have to write their characteristics, you can write that alpha particle show deflection. And when you write beta particle, you will say beta particle show deflection, but in the opposite direction, than alpha particle. Or in opposite direction from the alpha particle. So beta particle do show deflection, but in the opposite direction than the alpha particles. Everyone understood this alpha, beta, and gamma radiation comparison? If there is any problem, please do let me know. Safiullah, Beta, you have any problem?
No, sir.
What about Yamna, Armina, Asjad, Ibrahim?
Sir, can you explain cathode and anode again?
See, cathode means very simple. Cathode means negative electrode. Anode means positive electrode. Cathode being negative, it means alpha particle turn towards the cathode, negative terminal. And beta particles being negative turn towards the positive electrode, that is anode. So cathode, we give name to the negative terminal. Remember that. Negative terminal means cathode, positive terminal means anode. Everyone understood this topic? Clear, everyone?
Yes.
Good. Okay, now let's come to another topic relevant to that. That whatever we are doing, we are just understanding that what are the qualities of alpha, beta, gamma radiation. Now we will see what it affects when any one of the rays are getting out of the atoms during radioactivity. Okay, because our main topic was radioactivity, and during radioactivity, alpha, beta, and gamma radiations are coming out. How does it affect your atom? Okay, so now we will talk about the equations relevant to that. Now check this out. Neutral, okay. Now, what happened to the alpha? I mean, what happened when the alpha particles are actually emitted, or what happened? Let's see it. Okay, now the important thing is, few things I will write it here, and then few things definitely I will let you know. When the alpha particle is knocked off, let's suppose you have a material, any material, let's suppose X. If I say there is a decay of alpha particle, this is your A and this is your Z. This A means nucleon number and Z means atomic number or proton number. When there is an alpha decay means helium 2,4 is coming out. Your nucleon number will be reduced to 4. So your nucleon number -4 will be left behind and your proton number will be reduced to 2. Mass number will be reduced by 4 and your atomic number will be reduced by 2. Put a heading alpha decay and write this, please. Alpha decay. Write this equation. And write few lines. Then once you write it, then we will write few lines as well. When alpha particles are emitted from an atom, nucleon number is reduced by 4. Nucleon number is reduced by 4 and proton number is reduced by 2. And proton number is reduced by 2. Let's see an example here. Check it out. You can see an atom that is called radium. If you see a periodic table, you will find that this is basically an element in the table having atomic number 88 and mass number equal to 223. When I say that what is the atomic number or mass number of an element once the alpha decay is being occurred, then you can do that. You will see here that 88 is reduced to 86 and 223 is reduced to 219. So basically, your radium will change into a new element that is called as radon along with the helium nucleus, or you can say with the helium particles. So did you see that? Did you notice that your one element that is a radium is completely changed into a new element that is called radon? So in that way, actually, alpha particles do occur. I mean, alpha particle or alpha radiation do occur in this case. So write this equation, please. This is one of the examples of alpha particle emission. Guys, any problem in this equation? Alpha emission? I hope there is no problem. It's a very simple equation. Now, if you want to check your equation, whether you're right or wrong, we know that left-hand side must be equal to right-hand side. Check it out. Here, there is only one element. 88 is the atomic number. Check it out here. 86 plus 2, which is equal to 88, sorry. And numerator, the mass number is 223 here. 219 plus 4 gives you 223. So left hand and right hand both are equal. It's same like we do it in chemistry. All right. Now let's move further.
Sir, I have a doubt.
Yeah, you're saying something?
How did the denominator increase for the numerator? Sorry, the denominator decreased and the numerator increased.
It's not denominator, it's atomic number. Why? The reason is very simple. Check it out. Atomic number of helium is 2, right? So when helium is out of it, then it means 2 positive charges are also removed. So out of 88, when 2 is removed, it's left with 86. But as far as mass number is concerned, it means 2 proton plus 2 neutron. So basically, when 2 proton and 2 neutrons are removed, your mass number is reduced by 4 numbers. Understood? It's same like a helium nucleus. When it comes out from any particular atom, the mass number reduced by 4 and atomic number just reduced by 2.
So
Understood,
that's
Ibrahim?
just 9. So that's just 9.
Not 9, you can say. Mass number reduced by 4, it's separate. And atomic number reduced by 2. Two separate things, absolutely. Because mass number also
Okay.
include your number of protons plus number of neutrons, technically. So it means that your neutrons are also removed. If you are asking me exactly what is removed from it, so I will say to it 2 protons and 2 neutrons. 2 protons means atomic number reduced by 2, and 2 proton and 2 neutron means mass number reduced by 4. Because 2 neutron plus proton had to give me nucleon numbers. All right, understood?
Okay.
Good.
Yes.
Okay, this is another one. Check it out. Wait. Did you notice uranium 235 92, when alpha decade is happened, it reduced to thallium 90 and 231 and helium. Helium nucleus is basically alpha particles again. So uranium is converted into thorium along with alpha particles. This is again an example of alpha emission. Another equation. The question may come to you that maybe the thorium will be written here like this, but they didn't write any atomic number, or you can say proton number here, and no number will be written on the top. You have to write these numbers. So you know that if uranium is 235, it will reduce by 4. So it will be 231. You have to place it here. And out of 92, you have to write 90 at the place of atomic number. Right? Write this equation as well. These are the two examples which I just showed it to you. They are alpha decay. Now these are other equations, please. The one which we have written at the top, it's the same one. And there is another equation. I can show it to you here. See in the last one. That's americium 243. This is an other element at in periodic table. When alpha was decayed, alpha is decayed from here, it will change into neptunium 239. So again, the mass number is reduced to 239 from 243, and atomic number is reduced from 95 to 93. Write that equation as well at the bottom. So there will be altogether 3 equations. Guys, any one of you have any problem, you can consult my videos as well, which I am uploading continuously. For that, you can contact our coordinator and he will provide you the video link so that you can download it and you can see through that as well. Still, if there is a problem, you can ask me by message me directly. If I'm available, if I'm free, I will get back to you. All right. Everybody copied? I hope everyone copied. Now put a heading beta emission, beta decay or beta emission. Now write this equation which I am writing here. Let's suppose you have again X. This is your Z, atomic number. This is your A, that is mass number. When beta is decayed, your atomic number or proton number will be increased by 1 and your mass number remain the same. This is your beta emission. So when beta is decayed, technically speaking, your atomic number is increased by 1. The reason is very simple. 1 neutron actually converted into proton due to beta decay. So basically, when neutron become proton, the protons are increased by 1, but as a nucleon number, sum of proton plus sum of neutron will remain the same. That is the reason A value doesn't change, but proton value increases. If you ask me one by one, number of proton, number of electrons, and number of protons, neutrons, then you can say that proton will be increased by 1, neutron will be reduced by 1, and electron will be 1 less than the protons. Oh, sorry, electron will be remain the same as the protons. So proton and electrons are same, while neutron will be one less than the protons. By the way, there is nothing called electrons in this whole discussion. We have just proton and neutrons here. Anyone have any question in this beta decay? Okay. If you write this equation, write few lines. During beta emission, during beta emission, during beta emission, one neutron will be converted into proton. One neutron will be converted into proton
So can you say again?
during beta emission or beta decay. One proton, one proton, one neutron will be converted into proton. One neutron will be converted into proton. So, proton number will be increased by 1. So, the proton number will be increased by 1. And nucleon number will be same. Nucleon number will be same. Nucleon number will be same, even though number of neutron is 1 less than the proton. Number of neutron will be 1 less than the proton in the new element nucleus. In the new element nucleus. Everyone understood this? Armina, Yamna, Safiullah, Ibrahim, Asjad. Any problem in this?
Yes, sir. Yes, sir.
Yeah, good. So now let's see an example for this. It means that in that case, the atomic number will be increased by 1. So let's check it out. This is one of the examples which is right in front of you. You can see there, you have a radioactive element carbon 14. It's converted into nitrogen and mass number remain the same with the beta emission. Write this equation, please. Safiullah, if I ask you, what is the difference between this nitrogen N714 and carbon 614? I'm actually asking you, how many protons are there or neutrons are there in nitrogen and in carbon? So what you will tell me about that? Can you give?
So, sir, nitrogen loses an electron or proton. Sorry, it loses an electron and makes carbon 16. And there's 7 protons in nitrogen, 14 protons and neutrons in nitrogen, 14 in carbon, 14 protons and neutrons in carbon.
No,
and
no, 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 no.
six.
I tell you, wait. First of
Yeah.
all, a very important thing is carbon actually emitted a beta radiation from there, right? So if I ask you the carbon nucleus only, it has 6 protons, proton number, and neutrons are 14 minus 6, mass number minus the atomic number, which is equal to 8. It means 8 neutrons. So number of protons are 6 in that, number of neutrons are 8 in this. And number of electrons will be the same as the number of protons. If you're talking about this nitrogen, it has 7 protons, right? Definitely 7 electrons. But as far as neutrons are concerned, previously they have 8 neutrons, right? Now at this place, 1 neutron is converted into protons. That's the reason you increase by 1 proton. So basically, the number of neutron is reduced to 7. So here 6 and 8 combines to give you 14. Here 7 and 7 combines to give you 14. That is the reason, if you can see here, the proton numbers, I mean, your nucleon numbers are same as the carbon one. But actually, if I ask you what is the proton and what is the number of neutron in that proton number is reduced, it is increased by 1 and number of neutron is reduced by 1. Understood, Safiullah?
Yeah.
Good. Who will tell me that when gamma radiation are coming out from any material, what will happen?
Yeah, sir, it's gonna stay the same.
It will stay the same because nothing actually happened. They do not have any mass. They do not have any charge. So gamma radiation, when comes out, nothing happens. So you just need to memorize this alpha and beta radiation. That's it. These are further here. You can check it out. Cobalt is changed into nickel, technically. So again, beta radiations. I want you to write that as well. Then there is a further one in here. Radium is converted into actinium. Iodine is converted into xenon. Okay, one more thing. It's written all beta minus particles. Remember that this is the only thing we have it in our course. Otherwise, beta has 2 radiation, 2 type of actually emission in that. One is basically when it becomes negative and one it becomes positive. So we have only have positive one in our course. That's the reason I'm not going for any other beta decay. By the way, beta have 2 type of decays. One is beta minus particle and one is beta plus particle. We do not have beta plus one in our course. All right.
Sir, can you show like how the gamma decay happens?
Yeah, that's
or
right.
is there a gamma decay? Okay.
Actually, there is a gamma decay, but gamma decay doesn't affect anything like this one. If you check, if you see here, thorium is 90 and 231. After the gamma decay, it will remain the same because gamma doesn't affect either atomic number or the mass number. Both are same. Same thing written in the end as well. Nickel. If you check this out, it will remain the same. So nickel will be nickel, right, even after the gamma decay. So if you want to write it down, put a heading gamma decay and write these 2 equations. This one and that one. And write it down that it doesn't affect the mass number, or in other words, nucleon numbers or proton number of an element. Right? No change. Write these 2 examples, one with the thorium one and one with the nickel one. I hope everyone written this. Okay. So let's move to the new topic in the
Sir, I'm
same.
writing.
Okay, please.
I'm writing. Just give me a minute.
Okay, no problem. Just do it. Okay. Now, once we're done with this all, now what we left with this is not in our course. Now, another small topic. I want you to write them. We will discuss them in the next class, but first I want you to write these. I want you to write this nuclear fission reaction. Write it, please. What exactly it is, we will discuss this in the next class. Write everything what is right in front of you. Along with the process of nuclear fission as well. This is the next small topic related to this chapter. As soon as we have finished, guys, you tell me after finishing this chapter, you want me to start with astrophysics or you want me to start with magnets and electromagnets?
Magnets.
Magnets. What about you, Armina, and other ones?
Magnets.
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 Everybody is saying magnets, so we will do magnets. After magnets and hopefully astrophysics, then we will left up with only the classic physics topics, right? So once we do that, I will take a quick look on the past papers related to these chapters as well. One or two classes or maybe three classes, we will take it with the past paper. And before I jump for the classic physics, I want to take one test of you people, everyone. So we will have a test class as well. But that everything will happen right after the Eid, inshallah. Ibrahim, when is your examination? Physics examination, final one? The first exam is when?
In May.
I know in May, but what day of May? I mean, what is the day? 15, 16?
It's on. I have to check.
That's fine. Check it out and let me know afterwards. Check me the dates. Right? As far as my knowledge is concerned, it's somewhere around 15 and 16, maybe 13, I think.
Yes,
Because,
I think it's on 15.
yeah, because in Pakistan, our examination, GCSE examination started in April, and physics exam is right there somewhere in the mid of April. Not April, sorry, in the mid of May, I believe. So hopefully, before our examination, we will have some past paper practice as well. And how many of you are planning to go for A levels basically? Right after finishing this? No one?
I am.
Okay, so
Sir,
you,
sir, the MCQ is on 13 and the practical is on 16.
and what about the paper 4, the alternate to practical thing?
Yeah, alternate to practical is alternate to practical, yeah, that's on 5th June.
Oh, so we have time for that. So we have to actually work for these two first. And then inshallah,
Yeah,
when the time will
MCQ
come,
and ATP.
in, MCQ and the main paper is on, in the mid of March. And then, so not March, mid of May. And then alternate to practical is somewhere in the June, right?
No, alternative practical is on 16.
How?
I'm confused.
No, man. Alternate to practical is late. Check it out once again. No problem. We will see to it. But first, copy that. Tell me in the next class. Till I will check as well because my knowledge is saying that alternate to practical is the last paper I think.
Okay.
But first, you confirm it, and I will confirm it as well. Don't just say that.